Hello everyone, welcome to the second video lecture that we are going to talk about authentication. Uh, as a kind of refreshing, as you remember, we talked about the authentication and we said that we have two major steps in authentication. One is the step at which we register a user, and the other one is the step that at which we authenticate the user. And yeah, here is a model that considers the registration, and then here is the authentication. And we've talked about the details of each, sub-steps of each. And then we said that in this authentication, this model of kind of registration and then authentication, one important property or one important item that we need to have is something that we call it a token. A token is something that we defined it this way. We said that a token is something that the individual or the user kind of knows, or something that individual possesses, like a physical token, something that individual is, like static biometrics parameter, or features like fingerprint, and or finally something that the individual does, like voice pattern or handwriting pattern or stuff like that. Out of these kind of four different categories of token, of course, something that the individual knows is the most widely used one, and out of them, password is again the most widely used one. So in this lecture, I'm going to use I'm going to assume that we focus ourselves only to password-based authentication, and I'm willing to talk about details of password-based authentication and kind of implications that it implies, uh, vulnerabilities that it has, and the way that basically it works. We start using kind of explaining some architectures of password-based authentications, and then we introduce different vulnerabilities, and we say count, or we kind of open or explain the countermeasures that have developed and introduced for those countermeasures, for those vulnerabilities. Okay, so let me go to the slide. Okay, here is the uh, kind of slide that we are going to start talking about password-based authentication. Of course, like I said, it's one of the most widely used approaches of authentication. And the way it works, user provides a name or a login or ID aligned with a password. And the system or the kind of server compares the password against a stored one. And if these two matches, it means that the entered password is correct and the user is a legit or valid user, and the user is now authenticated. Of course, there are a list of vulnerabilities for them. I have just listed them here. Later, after I explain how the password-based authentication works, we return to the kind of vulnerabilities and attacks that they may define against password-based authentication, and we'll discuss them in more details. But now for one example, let's look at a real password-based authentication system, which is used in Unix computers, Unix operating system. And upon being used in Unix, we'll see it in many distribution of Linux as well. Okay, so you remember, we have already talked about this, that the password is not supposed to be sent to the server as a plain text. Even if you are a new user and you want to register onto a system, you want to subscribe and get kind of registers and get registered, and after that you want to use some services from that server, your password is not supposed to be sent as a plain text to the server, because that's kind of contradictory. That's a contradiction, and if password is that important to me, why should I be sending it over the network? That may brings many problems. Mm, first of all, the server itself will know my password exactly. This is not what we want. And secondly, more importantly, uh, kind of the journey that password has when the password is supposed to travel the network and be transmitted from the client side to the server side, that's again is something dangerous. The only time that we can imagine about storing a password uh, in the server side as a plain text are for the systems that they are work locally. For example, you have a computer. In that computer, a Windows machine or a Linux machine, doesn't matter whatever type of operating system is, but you define multiple users, let's say 2 users or 3 users, and each of them has a username plus a password. Here, the password is not supposed to be sent over the network. So there is not that vulnerability does not exist here. So there might be, of course, even for modern operating system, they don't store the passwords in plain text. But the only situation that I can see might be to some extent acceptable is if you want to save passwords of multiple users on a local computer. Like the example I gave you, you have a computer with multiple users and they want to connect to that computer locally. The passwords are not supposed to be sent over the internet, over the network. Sorry, this is only case that might be acceptable if you ask or if you transmit the passwords from the user to the operating system as a plain text. Otherwise, if the case is a network based, here let's say this is a server and here is the client, and the client has already registered. When the client enter the password, so the client enter username, let's show it by U, and a password, let's show it by P. The username will be sent as is as a plain text to the server, but the password is going to be hashed. So what the server receives is a hash function of that password. And this happens even at the registration phase. At the registration phase also, the server doesn't receive the password as a plain text. Instead, it receives the password in a hashed version. So the password is the server received the hash digest of the password. So this way, the server or everybody in the network, or let's say everybody except the client percent, no one will know the exact plain text password. So yeah, this is kind of a minimum requirement that we need to agree upon. Okay, in the Unix-based password authentication, the system works this way. First, let's assume that, again, here we have two scenarios or two situations. One, you want to load a new password to the system, which is basically another description for the registration phase. You want to register a new user. And the second phase or second step is once you want to authenticate a user. In the registration phase, though, it works this way. It doesn't simply save username plus password or username plus hash of the password. It works a little bit more complicated than I'm going to talk about it. Okay, user is going to select a password, or a password is going to be assigned to user. When I say assigned password, it doesn't mean that the server dictates that. Server may generate that. Server may may ask the user to run something at the client side, and that application generate the password. So again, the password is being generated at the client side. Anyway, user will have a selected or assigned password, and of course, the password, the hash of the password is going to be taken, or if that's a local system, the password itself might be sent. And then password or its hash, every time here I say password, I mean in fact the hashed version of the password. Or if it's a local system, it might be the password itself, or password plain text. The hash of password or the password plain text is going to be combined. This is the registration, what we are going to store in the server side, at the server side here. The password, the hash of password plus a salt. Here you see this is a password or hash of password. So this is item 1, which comes from the user side. A salt is being generated at the server side. So we have 2 things. And these 2 are going to be again hashed using a specific type of hash. We call it slow hash. And I explain why we say a slow hash and how it's different than the normal hash functions that we know. These 2 are going to be hashed, and whatever we get is going to be stored in a table like this. We get the user. Of course, the username also came from the client side. The username also came from the client side. So let's say item number 3 is the username, that it comes in plain text. So let's say my username is Ahmad. So I say Ahmad, here goes Ahmad, my name. And then uh, the hashed version of the hash of my password plus a salt, whatever it is, let's call here X, for example. X also is going to be stored here. And then the salt value. Salt basically is for example, 12 bits or 64 bits random data. And here are the salt. So this row is going to be stored in the password file or password database at the server side. So this is how a new user is being registered at the server side. So again, hash of the password comes from the client side. Username comes from the client side. And a salt value is going to be generated at the server side. Salt plus the hash of the password, they are going to be hashed again, and they generate a new value, let's call it X. And each row of the password file, it consists of the username, salt, and the hash of password and salt, which we called it X. And a table like this will be populated for different users. And then when it comes to logging in, when the user wants to be authenticated, in fact, the user again sends the username in plain text, and of course the password in a hashed or hash of password. So these 2 are going to be received from the user or from the client. The username or user ID is being used in order to point to a specific row of this table. Or let's put it this way, the username will be used to find a specific row which relates to that user. So the server side goes to this specific row, and here it takes the salt value. The salt is here, the random number that the server generated at the time user wanted to be registered. It takes the same salt, it hashes the server side, hashes the hash of password with the salt another time for the second time. It gets a value, let's call it X prime. And here, of course, is X. X prime and X are going to be compared against each other. If X prime and X match, it means that, right, the uh, the password that this user has sent is a password that this specific user has been registered with. So this is a valid password and the user can be authenticated. If these two are not the same, it means that someone is pretending that he or she is user, for example, Ahmad or whoever. And of course, he's not or she's not. She's trying to attack the system because the password provided is not matching. And this way you see the server never knows the password. And the server only requires to know the hashed version of the password. And of course, it's going to be very difficult for the attacker to attack this system. One question you may have is, why do we need to use a salt value? What is the kind of role of having this salt value? For talking about it, I'm gonna, I need you to wait for a few moments, maybe for 10, 15 minutes. And after that, I'll introduce some of the attacks. You will see that if there is no salt value, it's going to be sometimes very easy for attackers to guess password without knowing it, just by guessing, because it's going to be a hash function, and I just need to apply different inputs and look at the output of that hash function and try to see if the hashed value of me matches the hash value of the password file. Of course, in that case, I need to get access to that password file. So I'll be talking about it in a few moments. And the other thing that is kind of need attention in this slide, or in this kind of example, is a slow hash function. What is a slow hash function? Basically, it is a hash function, but it takes kind of more time than normal hash functions to be finished. For example, it is not like a single, like our simple hash functions, for example, SHA 256, that it being computed in a very fast on a few cycles. No, because we want to intentionally keep it slow, because if someone tries to attack, we don't want to respond them very quickly. If you are an attacker and you want to apply multiple random or guessed passwords, I shouldn't be replying you very fast. Basically, it relies on this idea that if you are a legit user, you know your password, and you don't want to try multiple things. Maximum 2-3 times is enough for you. So you don't need me to be very fast. If you want to trick me and if you want to apply multiple passwords, it's better for me to be slow. That way I can protect my legit users. Okay, now I'm going to talk about some of the known kind of vulnerabilities or attacks against password-based authentication. And also I'm going to introduce the countermeasures. The very most famous one is called offline dictionary attack. Offline dictionary attack, it works this way, that someone may get access to the password file. Here, this is a password file. Of course, this is a very important thing. And if I'm an attacker and I get access to this password file, still I cannot do something, because all the passwords are here kind of in the hashed format. So I cannot get the actual password, but I can come and I can generate multiple passwords, and I can, of course, check to see which generated or which random password generates the same hash function. So I have a file and I look at it as a dictionary. This is the, let's say, hash of the password. I guess a password. Let's say I assume that my password is, for example, Ahmad. Let's say 123. Okay, I calculate the hash of these, and I come here and compares the hash value again, different hash values. I check to find that in the password file. If I find it, it means that okay, my guess was okay, and this is a password for that specific user or for one of the users. So if this is a kind of time that we can say this is one of the cases that the importance of the salt value here shows itself. If there is no salt value, it's going to be very easy for the attacker to guess the passwords after getting access to the password file. But if we assume that there is a salt value, the attacker must try different salt values as well, which makes the attack kind of even more complicated or more time consuming. So what are the countermeasures for this offline dictionary attack? Of course, the basic idea here in the countermeasures is that we want to make sure that the password file is protected. If we can guarantee that password file will be never leaked and the attacker will never can access the password file, there is no dictionary attack. But of course we can't make that guarantee. We can never ever say that the security of a system is 100%. It's always something less than 100%. So some countermeasures kind of include controlling the system to prevent unauthorized accesses to the password file, application of intrusion detection mechanisms or measures in order to detect and identify if the password file is being kind of attacked. And another countermeasure might be something that we have already kind of experiencing: rapid reissuance of password if the password file is kind of compromised. If I know that the password file is compromised, one easy thing is just quickly email all the users and ask them change their password. This is, for example, what you see in ANT system. They just asked a few days ago that all of us need to reset our passwords. Of course, the password file here is not kind of leaked, but and they want to do it just for kind of assurance. But I'm saying that the same mechanism, the mechanism is similar, but here, you know that obviously we haven't lost our password file. Okay, another attack that can be designed for password-based authentication is called a specific account attack. In this attack, the attacker targets a specific account and submit multiple passwords for that specific account until the time that password is discovered. So for example, I know the username is, for example, let's say Ahmad Patugi, and I'm gonna apply different or submit different password for this person. So I kind of stick to one user and try to apply different passwords for that person in order to guess his or her password. And of course, as an easy countermeasure for that is account blocking. Account can be locked out if you try multiple times. Normally, people say more than 3 or more than 5 times. If you apply a password and the password is not correct, your account will be locked. So this is how you can protect against specific account attack. There is another attack which is very similar to a specific account attack and called password guessing against single user. And that one, again, focuses on a specific user or on a single user, but here the user is somehow known to the attackers. So attackers attempt to gain knowledge about a person. For example, someone wants to attack my account and they want to crack my password. So they try to collect some information about me. For example, who I am. They may go online and collect some information about, for example, what's my education degree, what's my area, where I have worked, and information like this that basically shouldn't be very difficult to collect for people. And after they collect such information, they try to implement now different guesses for that specific person or that specific user based on that knowledge or that information. Another thing that might be used here is the policies or password policies used in the organization or in the system, because different different organizations, they may apply or enforce for different password policies. Okay, countermeasures for this attack include this: enforcing of password policies to make password difficult. So password policies, applying or enforcing for complicated or advanced password policies, like for example, minimum lengths or character set, prohibition of using well-known identifiers, like for example, name. For example, if my name is Ahmad Patogi, Ahmad shouldn't be in my password. That you see, I'm sure that you have experienced this. Some servers doesn't allow you to do that, but some they do. Some they don't care and let you to pick a password that is kind of contains part of your first name or last name or both of them. Or another, for example, countermeasure might be the enforcing of password change in a given amount of time. For example, in my previous institution, every 3 months we had to change the password. Okay, another attack to passwords is called workstation hijacking, which basically means that you have logged in to a system somewhere, to a workstation, and you leave the system, you finish your work and you leave the system without logging out. So I can come, if I'm an attacker, I can come and use the logged in account and try to do something, try to, for example, change your password or whatever. Or you may leave the system unattended for a short amount of time. And of course, the countermeasure is logging out automatically after a period of inactivity, which of course you have experienced this in multiple kind of accounts. In your bank account, if you log in normally after 10 minutes, they kick you out and the session will be expired. Electronic monitoring: a password is communicated across a network to log in to a remote system. And of course, if the password is not hashed, it's going to be very vulnerable. So that's why we say we don't send the password itself unless we send the hashed version of the password. Okay, another attack that we may, or let's say another avenue for attacking password-based authentication is the application of open source password crackers. You remember when we talked about worms and Trojans and viruses, I introduced you a few applications that you could use them in order to develop your own virus. You may not know, because if you remember, I mentioned that developing viruses is not easy thing. You need to know details of computer systems and networks, and it's gonna be or Trojans. You need to know many things about network in order to, for example, develop your Trojan. But those applications help kind of, let's say, beginners or other people that they like to develop some malwares, and so some people use them in order to develop their own viruses or malwares in general. The same thing here for password crackers as well. There are some open source and some applications that password crackers may use in order to crack passwords in a specific system. One of them, for example, is here. You see the logo. It is called John the Ripper. And basically, they have started being developed in 1996. The first password cracker developed was John the Ripper. And it uses a combination of brute force and dictionary. So, which means that it tries to crack the password for a user. It tries to do brute force. If you don't feed it any extra information, it tries to just apply different password to see which one works. If you provide this tool a dictionary, it's going to be more efficient and it works faster, tries to reach to the goal or crack the password faster. Okay, you may wonder if really passwords that we are using are guessable or not. There is an experiment done in this regard, which kind of gives a pretty interesting, reach to pretty interesting outcomes. They have tried, a group of researchers, they have tried to crack passwords of 25,000 students in a research university in the United States. With a complex, of course, in that university, complex password policies were enforced. We will talk about the password policies, and you see that it means that you couldn't use normal password, like for example, username 123 or Ahmad 123 or something like that. Those passwords were not allowed in that university. So out of those 25,000 students, the attackers, of course, they of course didn't have access to the password file, because the password file is something that it's not easy to get access to. But instead, they had access to some similar password file. For example, here is one. RockU is a password file which has already leaked from some institutions, and they're available online. And basically, that gives pretty much a good amount of information for the password guessing. So they looked at the policies. This is the first input. They looked at the policies of that specific institution. They looked at some password file from some other institution that they may or may not have the same policy. But the basic thing here, kind of that helps the attackers to crack many of the passwords. I say that they could do, they could reach 10% and then 40% of passwords cracked. The basic property is here is that humans are picking the password. So regardless of policies, of course, the policies force the human to come up with different passwords, but or when the policy changes, the password will change. But in background, we have some patterns in picking passwords, which we somehow can keep them almost the same under different policies. So here are the results. They could break something about 10% of passwords by by having 10 to the power of 10 different guesses. 10 to the power of 10 is 10 billion. 10 billion different guesses, after 10 billion guesses, which is here, basically it's even a little bit above 10%. It's maybe 13%. Oh, here is not logarithmic. Sorry, yeah, it maybe 12% of passwords were guessed. And after 10 to the power of 13 guesses, they could reach about 40%. They could guess about 40% of passwords, which is pretty scary number. And 10 to the power of 10, 10 to the power of 13 is almost doable, I would say easy doable for existing computers. And please keep in mind that here applying different passwords, it doesn't have that much complexity at the cracker side. It doesn't have that much complexity at the cracker side. Because you just want to generate a password and try it. Okay. What people do, what the security engineers do in order to kind of deal with these password cracking applications and password cracking successes is taking some modern approaches. The first thing is password policy. Password policies force the users to pick a stronger password. Although we should know that, again, like I said, there are two kind of items that they're working against password policies or complexing password policies. The first thing is, of course, the crackers are also humans. They are also they may have researchers, they may have resources, and everything at their sides is also improving. Resources, hardware, computers, their algorithms, their password guessing might be kind of enriched by machine learning or stuff like that. So everything at their side also is improving. That's the first thing, which is listed here. And second, like I said, even if we change or enforce different policies, still there are same patterns that our users try to fulfill. Let me give you an example. When you go to a website that says, for example, you should use you should generate a password, you should pick a password that has to have a specific character, let's say at sign or dollar sign, a set of them. Normally, the way that people work is that they have a general password and they just add this one of these signs that they always use that specific one at the end of or at the end of the password, or at the start of that password. So what I'm saying is that we as human, we have some patterns in generating passwords and try to use the same patterns as much as we can. This is against the complex password policies. And of course, one important thing that here again plays an important role is the security of the password file. Password file also is very important. If we can make sure that the password file is protected, the whole system or the whole passwords might be protected. So we can use let's say different type of countermeasures. For example, intrusion detection, or encrypting the password file in order to make sure about the security of the password file, or letting only privileged users or privileged processes to access to the password file, or defining shadow password file. That, of course, these are countermeasures, but there are vulnerabilities for each countermeasure. For example, if you define access control to the password file and you only allow a few users or few processes or privileged processes to have access to the password file. So now the access control mechanism is the place of kind of target, is the victim. People try to first kill that access control mechanism, and after that they can access the password file. So weaknesses in the operating system will somehow now comes against us, because if there is any weakness in the operating system that I can use it in order to kill that access control, I can turn off the access control and I can get access to the password file. Or accident with permissions, or if you accidentally give some permission to some user or some processes. Or a shadow file, having shadow password files is helpful, but at the same time might introduce new vulnerabilities because that shadow file might be compromised. Or sniffing the password over the network if the password is being sent in plain text. All of these means that it's not easy to say that there is no single solid solution that we can use it and just say that, okay, we are sure that the password file is now protected 100%. Okay, now let's talk about password selection strategies or password policies. For password selection strategy, we have multiple kind of options to go with. First of all, user education. It's very important to educate our clients or the clients of a system. That might be asking them to just learning them, teaching them that, okay, you need to pick strong passwords, or examples of a strong password can be shown to them because that might be the case for some of the users. Another strategy is introducing them or asking them to use computer generated password. There are some applications that they generate passwords for you. And of course, they're very helpful, but the problem they have is that it's very difficult to memorize them. And most of the time, if you generate a password using the application, you will end up saving it in a text file as a plain text somewhere, which is again contradictory or counterproductive. You don't want to do that. You will end up saving a, for example, 200 character password somewhere. Another strategy is the use of reactive password checking. The reactive password checking means that the system or the server checks different passwords, checks the password file, and tries to find those passwords which are guessable, which are easy for guessing, and then ask the user to change them. Of course, the server side, when we say they check the easy password, it doesn't mean that they can look at the password, because the password, like we explained, the passwords in the passwords file are basically hash of the password. But it doesn't matter. The client can generate easy password and take their hash, compute their hash, and compare with the password file. If something matches, it means that the user has picked a very easy password, and we can ask them to change it. And the last strategy that people may use or systems may use is complex password policies. Complex password policies means that we ask the users at the registration time, or we check their passwords if their password follow a specific regulations or policies. And the goal is to eliminate easy guessable passwords. And of course, we just doesn't want to, we just don't want to allow users to pick easily guessable password, and at the same time, we don't kind of force them to use passwords which are not easy to memorize, because that's again another thing. If we make it very complicated, the kind of it's a spectrum. At one side, it's very difficult or unguessable passwords. Let's say unguessable, and here is very easy and guessable password. So the left side can be achieved by the use of password password generating applications. But the shortcoming of that is the thing that the password is not going to be memorable for the user, and the user end up saving it somewhere as a file, which is again something that we don't want it. Okay, I'm going to talk about the complex passport policies and open it up, because we may pick different approaches or mechanism to implement that. We call it also proactive password checking. Proactive password checking means that we don't let the user to pick his or her own password and then we try to detect easy guessable ones. No, at the time that the user tries to establish the password or try to register, we apply some rules on that. That's why we call it proactive. Proactive password checking can be achieved through rule enforcement. Rule enforcement means that there are some rules, and the user has to fulfill those, or has to follow those rules, and has to fulfill some requirements. Per National Institute of the Standard and Technology, they have defined two password policies. One of them is called Basic 16. In Basic 16, there is no requirement. The only requirement is that the password should have the length of minimum 16 characters. And the second one is called Comprehensive Aid. Comprehensive Aid, it has the minimum length of 8 characters. So the password should be minimum 8 characters. And also it should have one uppercase, one lowercase, one at least one digit, and one of a set of symbols, which are basically include @, parentheses. It's a set of 7-8 different symbols. So this is called comprehensive aid. And the interesting thing is, based on some researchers kind of finding, the Basic 16 is superior in terms of being guessable. In fact, Basic 16 is less guessable than Comprehensive Aid. Although in most of our systems, our current system, we see that they kind of enforce for Comprehensive Aid, but Basic 16 is better in terms of protection. But of course, it is more difficult for just memorizing by the users. That's why most of the systems go with Comprehensive Aid. We also have automated rule enforcement, which means that there's a password checker, and the password checker checks some rules for the selected password. And the password checker may enforce some of the, for example, rules like Basic 16 or Comprehensive Aid, or might be configured by the by the system administrator. You work somewhere, you know that your user, for example, they may tend to do something or not to do something. So you want to implement, you want to enforce for a specific policy. So password checkers help the system administrator to define and implement their own policy based on the specification of their system. They may also do it this way, that they compile a large dictionary of passwords, which are, this is one way to kind of implement password checkers. They compile a dictionary of passwords which are not, which shouldn't be used. And if you use one of those passwords, the system reject your password. They say this is not strong enough. This is not good enough. Another automated rule enforcement is it's here, like I said, compiling a large dictionary of bad passwords that when you are going to register to the system, the password is going to be checked. Your password is going to be checked against that dictionary of bad password, and if that falls against one of them, if your password is one of them, your password will be rejected. And of course, there are some obvious shortcomings with this: space and time. The dictionary might be kind of get very big and might be very large, and the time of searching through that dictionary itself is going to be very kind of long, and it can take some time from the server side at the registration side. Please, for today's attendance code, use this word: enforcement. Use the word enforcement for today's attendance code. Thank you. Yeah. And the last automated rule enforcement is another example, or another application is application of some, for example, filters like Bloom filter, that they don't have any dictionary, they don't have any set of rules, but they define some type of filter, that the filter looks at the properties of the passwords and rejects the passwords that they're not good, they shouldn't be used. So they help the kind of the server to reject not enough strong passwords at the registration side. For example, one parameter that the Boom filter may work with is the entropy of the hash of the password that the user has used. So if the entropy is not big enough, is not good enough, it means that the password is not good, and that password might be rejected. I think that should be enough for today. Thank you for attending today's class, and we continue for in this lecture. We will be talking about other parameters and other tokens that might be used in authentication. We've talked about something that user knows, and we picked password, and we talked about password architectures and stuff, other things. Pins are pretty much similar, so we go to the next one, something that user may possess, like a token, like a physical token, and something that user may have, like a biometric parameter. And that's going to be the probably our lecture in the next week. Thank you for attending, and have a good rest of the day. Bye-bye.